Nanoscience is the study, manipulation and engineering of matter at the 1/1000th of a metre scale, the equivalent of a marble to the size of the Earth. In the nanoscale, light and matter behave differently than at the macro scale, often defying the classical laws of physics and chemistry. As objects get smaller and smaller, quantum effects take more of a prominent role. Characteristics of particles at this scale and their packing into larger structures determine thermal, mechanical, electrical and optical properties of materials. By applying nanoscience, materials can be made stronger, more durable, more reactive, lighter, or change in many other ways to meet our demands. Being a relatively new field, nanoscience has the ability to transform our future. However, we have already harnessed some of its powers. Electronics, medicine, energy, and the environment have all already been affected by nanoscience, even in our everyday lives. One common application of nanoscience that we see every day is sunscreen.
Sunscreens protect our skin from harmful ultraviolet radiation. But how do they do it? In the past, sunscreen has contained large particles of titanium dioxide and zinc oxide. These particles absorb photons of ultraviolet and visible light, enter into an excited state, and then dissipate that energy, effectively scattering it. But by reflecting visible light, these particles also gave sunscreen a white color. In fact, sunscreen used to be very white and chalky, like paint, and this was a problem because it deterred people from using it or applying it heavily. To solve this, scientists turned to nanoparticles. As particle size decreases to the nanoscale, the peak optical density, the degree to which they slow and refract transmitted rays of light, increases and is blue shifted. This means nanoparticles of titanium dioxide and zinc oxide scatter light of smaller wavelengths to a greater degree, better protecting against ultraviolet radiation. We can use these properties in designing sunscreens. Sunscreens use particles of titanium dioxide and zinc oxide that are 25 to 50 nanometers wide, making them transparent on the skin while retaining a high UV light absorbing capacity. No more paint-like sunscreen. In comparison to other UV filters, they are also more stable, requiring less reapplication, and are a low irritant and low allergen materials. They don't look like paint, so you're more likely to slather yourself in it, better protecting yourself against sun damage. So in the fight against skin cancer, sunscreens with nanotechnology are a winner.